Okay, so part 2. I wrote the new trig identities we had on top. So you'll see tangent squared, and we're dealing with sine squared, cos squared, how they equal, and the old Pythagorean ones. Okay, and really now we can really just interchange, right? If I know cos x squared is equal to this, well, that means it's also equal to this. I could set 1 subtract sine squared is equal to sine x divided by tangent x. I can set all these things equal now, right? Because we're dealing with squares. So first thing I was going to do is I have my tangent squared. I was thinking of why not just replacing it with our sine and our cos, just like you had thought. Okay, but I was going to do things one step at a time. So I'm going to replace my tangent squared with sine squared x divided by cos squared x. Okay, and now that's all divided by another number in itself. 1 plus tangent squared is equal to sine x. Now, let's do a little side calculation. What that actually says is sine cos divided by 1 plus tangent squared x. Okay? And this as a fraction would actually be over 1. Okay, that's, even though it's on the bottom of the fraction here, it's technically the top of a number, right? It's the top of its fraction itself. So when we multiply fractions, we gotta make it a multiplication question and flip, correct? Remember that rule? Okay, so this becomes 1, and this becomes 1 plus tangent squared x. So when I go to rewrite this left side here, what it's actually going to say is sine x squared times 1 is sine squared, x on top. Now on the bottom I have cosine squared x multiplied by, remember this would be multiplied by all of this, so this would have to be almost a distributive rule. Cos 1 plus tangent squared x, okay? So, and that's equal to, don't forget this side, squared here, squared x, okay? So now I've rearranged this equation a little. I have sine squared on top. I just kind of, hopefully I can try to just cancel out this bottom. Well, I have the distributive rule, cos squared x times 1 and times tangent. So I'm going to bring that over. Cosine squared times, cos squared x times 1 is just cos squared x. So I'll write my top part. So my bottom is cos squared x. And then plus cos squared x times tangent squared x. Well, I'm just going to say plus. I don't know what that equals, so I'm just going to leave it in that form. Cos squared x times tangent squared x. So I'm doing a lot on the bottom right now. Okay. Let's go look at our other rules that we had. If I go back to the top, I know that I had a tangent squared x and a cos squared x, and I know they equal sine squared. Okay? So I guess I could replace this with our sine squared. Okay? So let's do that. I can replace cos squared x with tan squared x with just sine squared x. So my next line is going to read sine squared x above cos squared x plus sine squared x. Correct? Does this make sense so far?
Yeah.
Equals sine x. Okay. And do I have anything where it says cos squared x plus sine squared x equals anything? I go back up to the top. It also equals. It also equals 1. That's really great. I just replace those two things with the number 1 now. So on the bottom, I can get rid of both of those and just put the number 1, which means I'm going to get sine squared x over 1 equals sine squared. And we know the 1's not important. So the left side is now equal to the right side. What we had to be strong with was our fraction rules there. This is where it got specifically confusing, right in here. Converting that into this was a difficult step. We had to know our fraction rules, so this was very important that you knew how to do this part here. Okay? Does that question make sense?
Yeah.
Okay. Well, like I said, a lot of it's practice. It's kind of, you don't know where you're going until you finally get there. Okay, and the 1 here, remember this question said, we'll write it in solid this time. This says cos x squared times 1 plus tangent squared. So this is a distributive rule, if you remember. So what I actually have to do is I have to take this and multiply it by both of the numbers inside the brackets. So when I multiply cos squared x times 1, I get cos squared x. And I multiply cos squared x times tangent. Well, I don't know what that becomes, so I just leave it as cos squared x times tangent. That's where the 1 went to. It turned into cos squared x, because I knew what that multiplied to. Does that make sense?
Yeah.
Yeah, okay. And then from there, we put in sine, and we equaled 1 and 2. All right, 7D. Okay, 7D. I didn't write the, you know what? Let's write the trig identities, because it's very important that we have those. So let me pause this for a sec. Okay, these are trig identities we just used before. We probably don't have to worry too much about the quotient one. We'll kind of try to focus on the Pythagorean a little. But, okay, from what I've got here, I have sine squared x plus 2 cos squared x minus 1 equals cos squared theta. Okay, well, we know with the 1, we're always dealing with something that has to do with Pythagorean as soon as we have a 1. Okay, so, you know what? First thing I'm going to do is I'm going to move the 1 to the other side, see if I can make anything of it. So, sine squared x plus 2 cos squared is equal to cos squared x. That should have been x, not theta. We're gonna. I know it says theta in the question, but we're just gonna change everything to x.
How do you know when to bring the 1 and
2? Really, it's not that. Is there a time and place? Because there's a million different ways you can solve it. It's just whatever's going to help you recognize identities, rules, the best. So I'm bringing the 1 over just because I want to see if I can make anything of it, if it'll show me anything on the other side. So when it comes over, it becomes positive 1. You okay with that?
Yeah.
Okay. When I look up here, well, actually everything deals with 1 subtract something. So I actually haven't made any identity. But what I can do is, you know what I might do now, is I'm going to move the sine squared x to the other side. So specifically, at first we did this, we moved this over, it became that. Next, I would like to move this over. I wouldn't have to divide because this actually says plus 2 cos. So it actually just becomes a negative sine squared x on the other side. So let's write that out. I'm going to move this over a little so we have some room. So this becomes 2 cos squared is equal to cos squared x plus 1 subtract sine squared x. Now, if we look at this, I can make an identity out of part of the right side of the equation. I have my positive 1, right? Well, I tried to cut the positive out, but 1 subtract sine squared x. Well, I do know that 1 subtract sine squared x is actually cos squared x. So I can actually replace this part. I keep the plus sign. I can replace that part with cos squared x. So let's do that over here. I have 2 cos squared x is equal to cos squared x plus, and I've replaced this, specifically this part here, with cos squared x. Oh, okay. Well, think of these like coefficients. There are technically coefficients in front of the cos squared x. You know what I mean by coefficients? Yeah. Okay, so technically in front of this cos is a 1, and in this one is a 1. So really, how many cos squared x's do I have? I have 1 plus 1. That means I have 2 cos squared x's. So when I add those two together on the other side, I end up with 2 cos squared x is equal to 2 cos squared x. Does that make sense?
Yeah, that makes sense.